Good morning. Today I will be presenting the findings of a 5-year survey of lake char populations at Stannard Rock, Lake Superior that was conducted in 2011 to 2015. Most of the Great Lakes has offshore shallow relief features that are islands or seamounts. There are 6 major offshore areas in Lake Superior shown with yellow triangles. And today I'll be presenting findings at Stannard Rock, which is about 55 kilometers from the nearest port. It is famous for its lighthouse, which is the most remote one in the United States and has been described as the loneliest place on Earth by the lighthouse keepers that manned it, starting in the late 1800s. Stannard Rock is also regionally renowned as a popular lake char recreational fishing destination in Michigan waters that supports a charter fishery catering to many tourists in addition to conventional anglers. For those unfamiliar, Lake Char is a major fisheries management focus in the Great Lakes. In the middle of the last century, intense commercial fishing and predation by the invasive sea lamprey extirpated Lake Char and all of the Great Lakes except Lake Superior. Recovery has been ongoing since the 1950s through controls on fishing and sea lampreys and stocking of hatchery fish. Lake Superior was the first lake to recover and is a rare management success story. Recovery is now occurring in Lake Char, and there are initial glimpses of it in Lake Michigan. Lake Superior is home to 4 ecotypes of lake char, also termed morphotypes since they are also morphologically distinct. The most well-known form and targeted by fisheries is the lean. It is the common form in all of the Great Lakes and inhabits waters less than 80 meters and has medium levels or intermediate levels of lipid, is both demersal and pelagic, and reaches the maximum lengths about 130 centimeters. The most abundant ecotype in Lake Superior is the Siskoet or fat lake trout, known for its extremely high lipid content. It lives in waters 60 meters to the deepest extent of Lake Superior, just over 400 meters, and reaches a maximum length around 100 centimeters. The less common ecotypes are the humper and redfin that are associated with seamount or island areas. The humper is the smallest form that inhabits depths between 40 and 100 meters and is demersal and has similar lipid levels as leans and only reaches a maximum length about 55 centimeters. The most recently documented and least known form is the redfin, and based on the few research studies on it, inhabits waters less than 80 meters, is demersal and has really low lipid levels, and attains a maximum length about 130 centimeters, similar to lean lake char. In 2011, our research station embarked on a 5-year survey of Stannard Rock with the goal of assessing the status of lake char ecotypes to guide management and to help address recent concerns by the public reporting lower catch rates of lean lake char, especially the trophy-sized fish. Our objectives were to measure and describe key population quantities such as relative abundance, size and age structure, growth, maturity, total annual mortality, impacts from sea lamprey predation, which is the major mortality source for lean lake char, and lastly, fishery harvest and effort. At Stannard Rock, we deployed both multi-mesh and single-mesh benthic gill nets at 6 fixed sampling stations during the month of June. Each year, 4 sampling stations were surveyed on top of the seamount in waters less than 80 meters, shown by the triangles, and 2 stations were sampled in deep water areas greater than 80 meters, shown by the circles. The 80-meter demarcation reflects the habitat differences between leans, which are the management focus, and the other ecotypes. The single mesh gill nets were only deployed in waters less than 80 meters and used to index lean lake char relative abundance to maintain continuity with historic estimates at Stannard Rock that were based on the same year. The multi-mesh nets were used in both depth strata. In our survey at Stannard Rock, we captured all 4 ecotypes. This is a length frequency plot of what was captured each year by 100 millimeter length group with the number of fish on the y-axis. The vertical dotted line at 500 millimeters is a reference line to help compare the length distributions. We mostly caught lean and Siskoet lake char with modest numbers of humpers. Very few redfins were captured, and this may just reflect our limited sampling extent at Stannard Rock. A broad range of lengths of lake char were captured, with many leans captured greater than 600 millimeters, which is the trophy class in Michigan waters. Siskoets and humpers had a shorter distribution of lengths. Humpers were mostly less than 500 millimeters, which is pretty consistent with the growth pattern of this ecotype. In terms of relative abundance, leans were most abundant at depths less than 80 meters, and humpers and ciscoids were most abundant at depths greater than 80 meters, based on our sampling. Relative abundance was indexed as the geometric mean catch per unit effort in units of fish per kilometer per night, and the error bars on here represent one standard deviation. Current lean lake char relative abundance at Stannard Rock, here on the right, based on our survey, was found to be similar to historic levels. The left panel represents relative abundance of leans after recovery from population collapse in the mid-1900s. To assess growth, condition, and maturity, I ran von Bertalanffy functions, weight length regressions, and logistic regressions of maturation as a function of length and age. The first panel graphs are data dense in that it displays the length and age relationships for leans, humpers, and ciscoids, as well as parameters from maturity functions. The individual points on the graphs are the length at age for each fish, and the blue curves represent the von B curves that were estimated. The vertical dotted lines are the age at 50% maturity, or A50, and the horizontal dotted lines are the estimated length at 50% maturity, or L50. Asymptotic length was estimated to be 891 millimeters for leans, 459 millimeters for humpers, and 938 millimeters for ciscoids. The L infinity for leans was likely underestimated as we tagged and released many large leans as a conservation measure. Leans matured earlier and at a larger size than the other ecotypes. Lake char have differing life history strategies and growth patterns, and a good way to look at this is to compare size at a given age. The length at age 12 was greatest for leans at 609 millimeters and lowest in humpers at 382 millimeters. Ciscoids were somewhat in between with 453 millimeters as the length at age 12. Condition, as indicated by the exponent of the weight length function, was allometric and robust for all ecotypes. Ciscoids had the highest weight per length, and as mentioned earlier, we caught very few redfins to do any thorough analyses. Population health was also assessed by looking at diet. This is a plot of diet compositions based on the proportional biomass of key prey according to Lake Char length group on the x-axis. The stacked columns are the percent biomass of prey organized from the benthos on the bottom to the diet items from the surface of the lake at the top. Invertebrates are the bottom three colors, and the light blue are surface items, which comprise mainly of terrestrial insects. The rest of the colors in between are various fishes, and the numbers on top of the bars are the sample sizes. The key take-home message from this plot is that lake char diet is diverse, comprising mainly of invertebrates when lake char are smaller, and shifting to prey fishes as they get larger. So it's an ontogeny shifting to fishes, which is consistent with other populations in Lake Superior. Interestingly, despite Stannard Rock being so far offshore, there are nearshore inputs as indicated by terrestrial insects and salmon found in the diet of lake char there. Here shown in light blue as the surface, which were terrestrial insects, and red as salmonines, rainbow smelt and alewife, both non-native fishes from nearshore areas, were also found in lake char stomachs at the seamount. One of the most important management quantities for lake char populations is mortality. Total annual mortality was estimated for leans, humpers, and ciscoids using catch curve analysis, and were found to be low relative to the management target maximum of 45%. Leans had the highest levels at Stannard Rock compared to the other ecotypes and compared with the adjacent nearshore populations. This is likely due to higher catchability here than near shore, and I'll talk about this a bit more in the next slide. Sea lamprey predation is a major issue for lake char and is indexed by quantifying sea lamprey wounds, and wounding rates on leans and ciscoids continue to be at higher than target maximum levels, which is 5% as seen on the right panel. Numbers next to the little dots are the sample sizes. This slide presents recreational harvest and release estimates at Stannard Rock for both the charter and non-charter fisheries combined on the left between 1990 and 2015. Note that release estimates were not measured for the earlier time period. On average, about 2,500 lake char have been harvested annually in recent years with high levels of releases. It's important to note that post-release mortality for lake char is about 40%, which makes mortality from fishing higher than just from harvest. In the right panel, fishery data indicate an increasing trend in harvest rates in recent years, which is contradictory to what anglers have been indicating. Some sport fishers have indicated that there were fewer trophy class fish and lower catch rates occurring at Stannard Rock and would like the state to issue more protective measures there. These data indicate a differing pattern than what anglers have been reporting. Because of the importance of Stannard Rock as a major fishery, as a conservation measure, we tagged and released any lean lake char greater than 600 millimeters that was in healthy condition. This is the trophy class. Typically, there are enough sampling mortalities of large fish to support data analysis. We tagged 197 large leans, and between 13 and 20% were recaptured by the recreational fishery at Stannard Rock, and none were recaptured anywhere else, indicating little to no emigration. What's important from this is that these data indicate that fishery exploitation is concentrated at Stannard Rock due to the seamount small habitat area for leans, and may likely create higher catchability in the recreational fishery, especially with the high release rates that have been measured and the mortalities resulting from those releases. To close, our survey indicated that lake char live long and prosper at Stannard Rock, with healthy populations and with broad age and length distributions. The exception is for redfins, as we did not collect many, which I think is due to the limited sampling extent, or they just may not be abundant out there. Lake char had growth and condition consistent with other offshore populations, which tend to have slower growth in nearshore areas. Total mortality rates were low for lake char, and the population support a robust recreational trophy fishery for leans. Some caution should be exercised if the management goal is to have a trophy level fishery, since the exploitation may be moderate due to the small habitat area of Stannard Rock, resulting in high catchability. This is important to concern in light of high release rates and the potential for high post-release mortality. Based on the social and ecological value of Stannard Rock, I suggest designating Stannard Rock as a state heritage fishing site similar to a blue ribbon trout stream. Finally, I'd like to thank my dysfunctional work family, the dedicated crew of the research vessel Lake Char, for their hard work. Thank you for being here, and I'd be glad to answer any questions.